Welcome back to AK Apt Logics. Today in this class, we are going to discuss about how to write design curve of NOT gate in a data flow model or the RTL model. So in the previous class, I have discussed about this code which is visible to over here. That is how to write the design code of NOT gate using gate level model. But today in this class, we are going to discuss how to write the uh, design of NOT gate using RTL model or the data flow model. Without any delay, let's move into the video. Before watching this video, I recommend you guys to watch that video and theoretical part which I am going to discuss earlier, which I have discussed earlier, so that you will have an good experience and clarity over Verilog and have a good experience and continuity in learning. So without any delay, let's move into the video. So now we are going to discuss about the RTL, right? RTL level model. So module NOT gate input A output Y, till this point everything is same, and end module is also same. Only the logic which is going to written in between the semicolon and the end module is getting changed. In the RTL model, what we are going to do is we are going to use the keyword that is assign, and then we are going to give the output. In this case, we are having the output as y, and we are going to use the equal to, and we are going to specify the logic using the operators. We are going to specify the logic using the operator. We are going to specify the using the logic using the operator. We are having the not operator as this symbol. This is the symbol for the not operation, and we are going to specify the input, that is A. So this is how we are going to write design code of NOT gate using RTL or the data flow model. Okay, I'm just discussing what is the part that is needed to be changed from the previous code. Okay, so that I recommend you guys to watch the previous code first, then only can able to understand the concept. Okay, in TB we don't need anything needed to be changed. Okay, we can use the same TB which I have discussed in the previous class. The same TB is can be used without any modification. Okay, first what we have done is we have used the module and given the TB name, and we have taken the inputs as registers in the TB and outputs as wires in the TB, and then we have instantiated what is the gate. We have instantiated the design module in the TB, and then we have used the initial block and specified the different combinations of input. That is, we are having only one input which is of the size of 1 bit, can have two different values, that is A equal to 0 and B equal to 1. So we have specified those values at different time instance, and we have given a delay, and we have given the stop statement using the $finish, and we have used the $monitor to print the output in the console, and we have used the $dump file and $dump wheres to see the output in the waveform. Okay, without any delay, let's run the code. Okay, if you want to understand this code of TB, you just visit the previous video, then you can able to understand it very deeply. Okay, I've saved the code. Okay, now I'm going to run the code. We need to select the open EPWave after run. Okay, this has to be selected. So let us see the waveform. So we've got the waveform which is having both input and output. Those are A and Y. Input is 0 from 0 nanoseconds to 10 nanoseconds. At that time slot, we can able to say that output is 1 from 0 to 10 nanoseconds. Similarly, the input is getting changed from 0 to 1 at 10 nanoseconds point of time. we can see the transition in output as well. That is from 1 nanoseconds to one logic 1 to logic 0. So this is how we can observe the output in the waveform, and the simulation is getting run up to 30 nanoseconds and more. So we are going to see the console output as well. See, we got the console output, that is time equal to 0. At 0 point of time we are applying the input test case as 0, and we are getting the output as 1, right? Similarly, at time instant 10 nanoseconds we are changing the input from 0 to 1. We are going to observe the change in output as well from 1 to 0, which leads to the logic of not yet, right? So this is how we are going to write the code in data flow model. Okay, and the TB will be same. Even TB will be same. Okay, when you are going to change any name in the design module like this RTL, if you are going to put like this not get underscore RTL, then you need to change over here, that is not underscore get RTL. That's it. Except that everything will be same. If you are not going to change the instance name or the module name in the design code, then there is nothing needed to be changed in the TB. This TB is sufficient for um, testing the design code. So this is how we are going to see. This is how we are going to write the code in the RTL or the data flow model. Okay, in Verilog, all you need to do is you need to focus on the design code itself. Okay, in the system Verilog, you need to focus on writing the test bench. Okay, so that I'm not going to discuss more deeply about the test bench. I'm going to discuss about more deeply about only the data flow model or the design code. Yeah. Okay, this is how we are going to see the out things. So I recommend you guys to have an hands-on experience in the Eda Playground. Okay, which will gives you an idea how to run the code, and gives you observation skills, like how to observe the output in the waveform. All these things you can able to learn by coding on your own. So thank you guys.